Welcome back to Mr. Mig's Classroom. I'm Mr. Mig, and today what we're going to do is we're going to discuss METARs and TAFs for the FAA Part 107 exam. If you've been keeping up with my videos, you've probably been watching the weather videos and the other FAA Part 107 videos. So what I've been doing is creating videos to help you pass the FAA Part 107 drone exam so you can get your drone pilot's license to fly drones commercially. In this video, I want to focus on the METAR and TAF section. I'll be straight up with you that you'll probably find between 2 and 4 questions on METARs and TAFs out of the 60 questions on the licensure exam. That's not to tell you not to study for it. I have a lot of students, the students who fail usually fail in the 60s, maybe even upper 60s. I've had students who failed by one question. So this could be that one question. So don't just say, hey, I don't want to learn METARs and TAFs because there'll only be 2 to 4 questions on there. There's a lot of things like that on this exam. The other thing is this is weather, and it will help you with the other parts of the weather by knowing METARs and TAFs. So yeah, please keep up. I think this is a good one to know, and this will be helpful with the other parts as well. Um, Okay. So with that said, let's go ahead and get started then. Oh, and before we get started, please like and subscribe to my videos. I really appreciate it. It really helps with the algorithm. I'm really close to 1,000 subscribers, and I really want to get there. So if you could subscribe, I greatly appreciate that. And click the like button. All right, so this slide here is just basically telling you, as the remote pilot in command, and as we've talked about in previous questions, you're responsible for pretty much everything. So you need to know the weather. Where can you get weather? Well, we got 2 weather reports we're going to talk about. The first one we're going to go over is METARs, and the second one we're going to go over is TAFs. Here's the big difference between METARs and TAFs. METARs are weather reports that are right now. So, what is the weather right now? It's how it's being observed at this time. They're issued on a regularly scheduled basis. If there's something important, then they might have another, like if there's a significant weather change, maybe they'll come out with something that's not on that schedule. Otherwise, regularly scheduled basis, automatically reported. Um, and here you'll see you get this little symbol in there, and we'll talk about that later if it's not in that regularly scheduled time frame. TAFs, on the other hand, they are a forecast. So METAR is what's the weather right now at this airport. TAF is what is the weather going to be like in the next 18 to 30 hours or whatever it might be. All right, so let's get into how to read METARs. Um, and I got that little graphic there because a lot of people complain about the METARs. They say, "Oh, these aren't fun. These are boring. These are this. These are that." Look, I I actually think these are fine. They're not that bad. It looks crazy at first. You're looking at this right here, and it looks kind of crazy. But I'm going to walk you through how to read this string of letters right here. So let me make sure I got my little mouse pointer. So uh, oh, let me do this. Oh, I hope you can see my mouse. Um, maybe if I do like this. No, sorry, I'm testing out a new screen sharing software, so please forgive me. Uh, okay, it's only working on the one screen but not the other. Next time I won't have dual screens when I'm doing this. Anyway, so let's just go ahead and go through it. So the first thing that we're going to go through right here, this KSOP, that's just the airport. So you might say, oh, that's kind of odd that it has 4 letters. Usually, don't they have 3? Like Raleigh Durham International Airport is RDU, not RDL. I don't know why that's saying RDL, but that should be RDU. But we put the K in front of it for everything in the contiguous United States. So if it's JFK Airport, that's really KJFK. If it's LAX, it's really KLAX. For civilians like us, we don't really pay attention to the K, but in the aviation world, it's just to let the aviators know, the pilots know that, okay, this airport is in the contiguous US. If we were talking about an airport in Hawaii or Alaska, they would have PA or PH. All right, so the next block of text is the date and time. And it's only showing you the day of the month. It's not showing you which month, it's not showing you which year. So this right here is going to show us that it's the 16th day of the month. We don't know which month. And then it's at 1630 hours. That is when this report was generated. the 16th day of the month at 1630 hours. We're using military time here, so that would be like 4:30 p.m. The Z stands for Zulu, and that's to let us know that this is universal aviation time. So here's the cool thing about in the aviation world, they have one time zone for the entire world. I actually think this is a good idea for everything. I don't. I like the idea of a one world time zone. Some people think I'm nuts when I say that. If you think it's nuts, put it in the comment section. If you like my idea of a one world time zone as they use in aviation, put it in the comment section as well. But you need to know this for the exam. If you are on an airplane that's taking off in, let's say, New York City, and then it's landing in Washington, D.C., that's both Eastern time. But guess what? The pilots on the airplane are going to use UTC time, and that's what the Z, the Zulu, is telling us. They're using UTC, otherwise known as GMT, Greenwich Mean Time. So that's the time zone that all pilots are using, all flights are based on, is the time that goes through Greenwich, England. It's that time zone there. For the entire world, again, even if the takeoff and the landing of the airplane are in the same time zone and it's in the Eastern time zone in the US, doesn't matter. We're always, in aviation, we're always using UTC. And you need to know that because they might throw a question out there that says, here's this METAR for KSOP. What time is this weather report based on? And it might say, this airport's in Eastern time zone, and it might say, oh, it's, 4:30 Eastern time. Nope, no, it's not. It's 4:30 or 16:30 GMT, right? Or 16:30 UTC. All those are interchangeable. UTC, GMT, Zulu. All right, let's go on to the next block. This is just saying the report was automatically generated. Sometimes there are these special reports and they'll put those out, but that's what the auto stands for. Pretty straightforward. All right, into the next block is the wind. The wind here is going to be the first three digits is the direction of the wind. So this wind is coming out of 30 degrees. Remember how we talked about in the airplane traffic pattern lecture that wind is based on where it's coming from, where the airplane is based on where it's going to. So they're going to be in opposite directions. So I want you to remember that. Airplane's based on where it's coming from. Sorry, wind is based on where it's coming from. Airplane is based on where it's going to. So this wind is coming out of 30 degrees, which would be about northeast, maybe northeast. And the 09, the second two digits in here, is the speed. So it's 9 knots. They like to use knots, not miles per hour. They will try to trick you here. They might say, okay, go to KSOP, look at this METAR. What is the speed of the wind that day? And they might put 9 miles an hour as an option. Remember that KT stands for not, so you need to know that. That's one of the areas they'll trick you. And that's what we find a lot on this exam is the FAA likes to kind of put in tricks like that. So be aware of that. All right. Every once in a while, you might see this VRB, which stands for variable wind. It means the wind's moving around a lot and it's not coming out of any specific position. And that would replace these first three letters. So they would put VRB instead of 030. Then you might also see something like if you look at the bottom here on this on this bottom bullet point, G indicates wind gusts. So you might see something like 03009 G 12 KT. That means that the sustained winds in this area are 9 knots with gusts up to 12 knots. Remember, if you have questions, please put those in the comment section. One other thing I need to say about the wind is what is it based on? True north and magnetic north. If you go back to one of my my longitude and latitude lecture, I talk about in there the true north versus magnetic north. Remember, the rule of thumb here is if you read it, it must be true. So if it's in print, it must be true. If you hear it, it's magnetic. So if it's written like a METAR report, it's based on true north. If it's if you hear it like if it's over radio, and I know you're reading the test, but every once in a while they might have a question where they say you're listening to CTAF. In that case, you're hearing it, so it's based on magnetic north. But on the METARs, you're reading it, so it's based on true north. Um, anyway, if you want to get a little caught up on that true versus magnetic north, go to my longitude and latitude section, and I talk about that and how true north is different than magnetic north. But you need to know that because they will have questions where they ask you, they'll say, look, go to this METAR here, this wind here, what's the direction of the wind at this airport at the time of this METAR? And they'll give you answer choices like 30 degrees magnetic north, 30 degrees true north, and then 18 degrees or something that's, totally off. Um, and you need to know that this would be, it's in print, so therefore it's true north. Let's see. Okay, if you got questions on true versus magnetic north, again, ask them in the comments section. Also, go and reference the longitude and latitude video I have. Next one up is visibility. So you'll see they have 2 1/2 here. This 1/2 is a half. So the visibility on this day, at this exact time that the report was created, uh, is 2.5 statute miles. One of the things they'll ask you on the test is they'll tell you to look at this METAR and they'll ask, could you fly a drone here that day? Tell me the answer. Go ahead, pause the video, think of the answer. The answer is no, because it's less than 3 statute miles. And remember, we need 3 statute miles to fly our drone. So we could not fly our drone this day. All right, that's that. Going over to the next one. Go through some weather in here. There's a lot of different types of weather. We'll look at that on the next slide. I think these are pretty straightforward. If you want to make flashcards for these, by all means. But I think like RA is pretty obvious. That's rain. The minus in front of the R is light. If there was no minus, it would be regular or moderate. If there was a plus, it'd be heavy rain. BR is the tricky one. You might want to make a flashcard for that. That stands for mist. Kind of odd. But a lot of the others are pretty straightforward. And you'll see that in this chart here. Um, we see drizzle is DZ, snow is SN, fog is FG. I think a lot of these are straightforward. I didn't make a flashcard for a lot of these. The only ones maybe, like I said, make sure you know mist is BR. They do seem to like to throw that one on the test a lot. So just be aware of that. Next is the clouds. So here's the cool thing about the clouds. It's a lot like on our sectional charts where we have to add 2 zeros. So you see BKN, that stands for broken clouds. Remember in the weather section, we talked about how the clouds, we split the sky into 8 parts. And so if if 5 to 7 of those 8 parts have clouds in them, we call that broken clouds. Overcast would be all 8 out of 8 parts have broken clouds. Remember, if there's broken clouds or overcast clouds, that creates a ceiling. So what they do is this 005 is saying how high the clouds are. We add 2 zeros, just like on the sectional charts, for our for seeing the elevation for the ceilings and floors of our airspace. We add 2 zeros there too. So a lot of times the FAA likes magic numbers. 2 seems to be one of those magic numbers. So we had 2 zeros. This means these broken clouds are 500 feet high. And then we got to ask ourselves, can we fly here? Because that's one of the questions that would ask us on the test. And the answer would be no, because we have to be a minimum of 500 feet. Our drone has to be 500 feet below the cloud base. Well, at 0, it's 500 feet. So if you go 1 foot in the air, you're less than 500 feet below the cloud. So we could not fly here that day because the clouds are not high enough. If we didn't have the broken clouds and only had the overcast clouds of 900 feet, we'd be fine. We could go up to 400 feet. But with the broken clouds, we cannot fly here that day. Here's that chart I was talking about. So you got clear days is less than no clouds in the sky. Few clouds is between 1 and 2 parts of the sky has clouds in them. Scattered clouds is like a partly cloudy day where you got 3/8 to 4/8, so 3 to 4 parts of that sky that we divide into 8 sections has clouds in it. Then broken is 5 to 7, and overcast is all 8 out of 8 parts of the sky has clouds in them. Next up is the temperature. So the first number is actually going to be our temperature, and the second is going to be our dew point. So 17 degrees Celsius, and you'll want to know that for our temperature, and then 16 degrees Celsius for our dew point. Here's the thing. I know it's tricky that the FAA likes to switch the systems, but they do. Sometimes we use empirical in distance, like they'll use feet and miles, as we can see with needing visibility of 3 statute miles. That's usually in feet and miles. Same with the heights of the airspaces is usually in feet. Um, but with speed of the wind, and same with speed of your aircraft, usually those are in knots. For example, 87 knots is the maximum speed of a drone or speed limit for a drone. And then in temperature, they like to use Celsius. So you got to be familiar with the fact that they switch things up, and they do. It's weird, I know, but they do that. So Could one of the questions they would ask you here is they might give you this METAR, and then they'll ask, could what's one of the hazards that you see from this METAR report at this airport on that day? And the answer would be fog. Remember that if the temperature and the dew point are within 3 degrees of each other, if they're coming together, we have an increased chance of fog. Here, the temperature and dew point are only 1 degree apart, Celsius, remember. And so that's pretty likely we'll have fog. Also, keep in mind that your dew point can never be higher than your temperature because the dew point is saying at what temperature the air will be fully saturated with water vapor. So you can't have more than 100% of the air being water vapor. Um, so eventually, what happens is that water vapor gets squeezed out of the air molecules and turns into fog. Let's see. And in case you skipped this or didn't go through this section, I do think this is important. They talk a lot about fog, so I'm just going to read through this note of temperature and dew point. When the dew point temperature and air temperature are equal, the air is said to be saturated. Dew point temperature is never greater than the air temperature. Therefore, if the air cools, moisture must be removed from the air, and this is accomplished through condensation. This process results in the formation of tiny water droplets that can lead to the development of fog, frost clouds, or even precipitation. Um, Let's see. Relative humidity can be inferred from dew point values. When air temperatures and dew point temperatures are very close, the air has a high relative humidity. The opposite is true when there is a large difference between air and dew point temperatures, which indicates air with lower relative humidity. Locations with high relative humidities indicates that the air is nearly saturated with moisture. Clouds and precipitation are therefore quite possible. Weather conditions at locations with high dew point temperatures, 65 or greater, are likely to be uncomfortably humid. Remember that dew point is actually a better indicator of humidity than relative humidity. All right. So what big thing there though, going back to the temperatures, just know that if the temperature and dew point are within 3 degrees of each other, we could see fog. Next one is the pressure. So here it's given our pressure in HGs. So just be aware of that. I don't see a ton of questions on that, but just know that this would be 30.18. So 30.18 HGs. That's the pressure that day. So they're just putting a decimal in the middle of those 4 digits. The next is the remarks section. I have heard one student tell me that they had a question on remarks. Normally, I don't hear about a lot of whole remarks questions. Just know that the remarks section always begins with RMK, and comments may or may not appear in this section. This is for manned aircraft to be aware of be aware of conditions that might be happening at the airport. Here's a full example of the METAR here. We can see we're in the Southern Pines, North Carolina airport. So there's the METAR, how it looks in text, and then it shows us everything that's going on in that METAR. Here's another example of the METAR. I'm just going to run through this one. Here we are at KLAX, which is the Los Angeles International Airport. First thing up is the wind direction and temperature. Or sorry, first thing up is the date. So it's the 16th day of the month at 16th day of the month at 20 hours and 8 minutes. So this is military time, remember, and that's based on Zulu or UTC time. Um, Next is the wind direction and speed. So the wind is coming out of 240 degrees and it's going 11 knots. Next after that is the visibility, 9 statute miles. Then we have few clouds at 2,000 feet and scattered clouds at 2,600 feet. The temperature is 22 degrees Celsius and the dew point is 13 degrees Celsius. This is more than 3 degrees of separation, so we're not likely to see fog here. And then we got our pressure 29.96 Hg. All right, cool. If you got questions, remember, throw those in the comments section. This is usually the figure they're going to have you reference when doing a METAR question. They're going to say, go to figure 12, or maybe there's a few others, but this is an example. Go to figure 12, and this is what the METAR will look like on there. It will say METAR, so you know it's a METAR report. Then it'll give the airport code, and then all the other things we just talked about. Go ahead and try to answer this question. So go ahead if you want to pause the video and answer it. What are the current conditions for the Chicago Midway Airport? All right, I'm going to go ahead and throw the answer up here. So skies 700 feet overcast. So we got overcast clouds at 700 feet with visibility of 1.5 statute miles and rain. And so we see that right here. This is going to be a day where we cannot fly. Not enough visibility, so you cannot fly that day. Here's another question. Go ahead and pause it if you would like to try to do this question. All right, I'm going to go ahead and read it out. The wind direction and velocity at KJFK is what? And so here we see KJFK. Here's the thing. This one's not so hard to find, right? 180 degrees, 4 knots. Oh, snap. Here's the problem. There's two answer choices that are exactly the same. So we know C is not right. So we know the wind is coming out at 180 degrees. We know it's 4 knots. Is it true or magnetic north? Do you remember? Remember, if it's in print, which this is, it must be true. So that's the answer here. Next up is TAFs. Remember, the difference between a METAR and TAF is simply that TAFs are a forecast of the weather, what's to come, where METAR is what's going on right now. So it's valid for the 24 to 30 hours following the report. And these are usually generated 4 times a day. This is a TAF. I know this looks crazy. It looks like a METAR on steroids. Do not worry. Once you get the METARs down, TAFs are pretty much the same thing with just more stuff. So let's go through this one by one. So first thing we looked at, just like in a METAR, is the airport identifier. So this is the Charlotte, North Carolina Airport, KCLT. Next thing we're going to look at is the date and time. So this is the 20, looking at this report was generated. So the origin of the report, not when it's valid for, but when it was created, was on the 22nd day of the month at 1124 hours. So it's 11:24 a.m. UTC. That's what that Zulu means. Remember that universal time. All right, so that's when the report was generated. The report is valid from the 22nd day at 1200 hours until the 23rd day at 1800 hours. So the first 2 digits here are still the day, and then the last 2 are kind of rounding out the hour because remember, this is a forecast. Next up is our wind speed and direction, or wind direction and speed. So the first 3 numbers indicate the direction of the wind is coming from. So in this case, coming from 230 degrees. And the next 2 indicate the speed, so 4 knots. Like I said, this is very similar to our METARs. Here's one little change. We got statute miles, same thing, 6 statute miles. They put the P in front of here. Anything that's greater than 6 is just going to say 6 statute miles with a P in front of it. And the next are our sky conditions or our clouds. So we've got few clouds at 6,000 feet. Remember, we add 2 zeros to this. And then broken clouds at 13,000 feet. Okay, so the next line is from. So now it's saying, okay, over time, obviously the weather changes sometimes. So this FM is from. So from 22nd day, starting at 1700 hours, this is what the weather is going to be like until the next, FM, which would be the line right below this. So the wind will be 240 degrees at 6 knots, maximum visibility 6 miles an hour or 6 statute miles, and then there's scattered clouds at 5,000 feet. Okay, moving on. And then the last thing was remember our scattered clouds. So the clouds, we just add 2 zeros. All right, next up, the next line we'll see is probability. So this is saying there's a 30% probability of whatever is on this line happening. And so this report was valid from the 22nd day, 22nd day of the month at 2100 hours until the 23rd day at 300 hours. Oops, sorry, going the wrong way here. Yep, sorry, went the wrong way there. Also, that now here 4SM is saying 4 statute miles of visibility, and then that TSRA, TS is thunderstorms, RA is rain, and then broken clouds, 5,000 feet because we had 2 zeros, and CB stands for cumulonimbus clouds. So not a very nice day, though. Technically above 3 miles, 3 statute miles visibility. All right. So another example of the TAF is this from again. So from the 23rd day of the month at 300 hours. Um, that's what it would look like, how they would use it in the field or um, all right. So next thing was the statute miles, 6 statute miles. And then we have our wind. Next thing is the clouds, scattered clouds of 9,000 feet. So, or sorry, 900. Yeah, 9,000 feet. So scattered clouds of 9,000 feet. So could we fly here? Absolutely, because the clouds are more than 500 feet above us. All right, and then this is what the TAF report looks like. If you got any questions on these TAFs, then make sure to ask me. And yeah, I'll answer those in the comment section. Let's do a couple of questions, and then I'll go ahead and close this video out. Refer to figure 15. What is the forecast wind for KMEM from 1600 hours until the end of the forecast? So go ahead and pause your video and take a second to look for that. Here's KMEM. Okay, and down here it shows variable in direction and at 6 knots. All right, well, that's the main things. Actually, let's do one more question. Last question we'll do is according to the KMEM forecast, what is the earliest time on the 12th day at which the visibility may be reduced below 3 statute miles for SUAS operations? Go ahead, pause your video if you're trying to answer this. All right, and the answer, if you look up here, is uh, the earliest time. So we see 1 statute mile of visibility, so that'd be less than 3, and that's going to start on the 12th day at 2,000 hours. I'm not going to go through hints here. I'm going to leave it there at the METARs and TAFs. So that was your METARs and TAFs. If you have any questions, please feel free to comment in the comment section. I'll do the best to help you out. If you could, please give me a like and subscribe to my video. I'm really on my goal to get to over 1,000 subscribers, and I want to really thank you for your help and support. Thanks for watching Mr. Mix Classroom. I'll see you next time. Take care.